Hello viewers, welcome back to my channel. Hope you are enjoying all the videos that I am uploading. If you haven't subscribed yet, please subscribe to my channel and share among your friends. So today's problem is minimum falling path sum. Given a square array of integers a, we want the minimum sum of the falling path through a. A falling path starts at any element in the first row and chooses one element from each row. The next row's choice must be in the column that is different from the previous row's column by at most one, right? So basically we are given with a square array, that is n by n array. So basically the number of rows and number of columns are same, right? So in that kind of array, we want to find out the minimum falling sum. Basically the path starts from the first row. It could start from any element in the first row, but it has to go through the first row till the last row. So the path should have first row through the last row. So that means n elements in the path, assuming that n by n matrix, right? So in that there should be n elements. So each element belongs to one row, right? But the way that you are going to choose the elements in that row is, so if you start at first row at an element, the next row choice must be in a column that is different from the previous row's column by at most one. So it could be in the same column, or it could be a column next to it, or previous to it. That's it. So you have three choices, that means, right? So the question description says next row's choice must be in a column that is different from previous row's column by at most one. So you can choose the same column, or the next column, or the previous column. So you have three choices, right? So that is what a little bit confusing here. The next row choice must be in a column that is different from the previous row's column by at most one, right? So it says it should be different from, and it says by at most one, right? So that means, so if you combine the at most one and different from, these are like quite opposite to each other, right? So it should be different, or it can be same column also. That's a question anybody would have. But the way that we have to understand that is, it could be same column, or a column plus 1, or a column minus 1. So you have three choices. That's what we need to understand. So if you look at the example 1 right here, 1 2 3 4 5 6 7 8 9. So this is a 3 by 3 square matrix. So so the first elements, that is the first column, is 1 4 7. So that is also one of the possible falling path. That's what it said in the explanation, right? So with that, what we can understand is, from this description it is confusing, right? So with this explanation, what you can understand is, it can be in the same column, and it can be in the a column plus 1 or a column minus 1, right? So there are three choices that we need to look at it, right? So let's go ahead and try to understand algorithm. So we are going to solve this problem with dynamic programming methodology, right? So what we are going to do is, we will be declaring some 2D array, two-dimensional array, with same number of rows and columns of A, right? So whatever the columns and rows that are given in the matrix A, right? So we are going to create a similar array, 2D array, and initialize all the elements in the created 2D array to the int max value, basically. So those are the maximum int possible value, right? And then fill the first row with the first row in the array with the first row of the A, right? So since there is no change to the first row, so 1 2 3 will be 1 2 3. That's it, because that is where we are going to start looking at the falling sum, right? So first row will be same, right? And next, that's where the DP technique starts. So from the second row onwards, we will have to go through the full row and try to identify which path is having the less sum, because that is what our final goal, minimum falling path, right? Minimum falling path sum. So we have to look for minimum sum, right? So in the array that we created, the sum array, right? In that we are going to collect the sum and put the minimum. As we know, there are three choices that we can look, right? So if you are starting from element ij, right? At the current element ij with the sum obtained at I minus 1 j, I minus 1 j minus 1, I minus 1 j plus 1, right? So that means, so you are at ith row jth column, that is a cell, right? So initially ij will be, to start with, it will be 0 0, right? So now for 0 0, what you are going to look is three choices, we said, right? The next row is I plus 1 j, right? I plus 1 is the next row and j, right? And I plus 1 j plus 1, so that is 1, and I plus 1 j minus 1. So those are the three things, right? So here what we are assuming here is, we are going to have three things, right? So we are adding I plus 1 and I minus 1 j, right? That is a addition, and I plus ij plus I minus 1 j minus 1, that is another sum, right? And ij, I minus 1 and j plus 1. So these are the three things that we are going to add and put the minimum sum in sum of ij, right? So there are three possible ways. So you are at ij, right? And what you are going to do is the previous, so here when we refer to I minus 1, right? So that is a previous row, right? From the second row, when we are starting to process, right? We are going to look what we are going to add for, right? So from the second row onwards, that means we have to look a row which is prior to the current row. Since we are processing the second row, we will look in the first row, obviously. So ij, I will be, since the arrays are 0 based index, I will be 1, right? So I minus 1 will be obviously 0, right? So if you are looking for 1 0, let's say, right? So there will be only two options. So for because first column you have only two options, right? So there is no like minus 1th column, right? That's why. So but if you are calculating for 5, let's say, right? So then you have this column and this column, two columns are available, right? So not all the numbers will have these three choices exercised, right? So some columns you only have two choices, right? Some columns we have all three choices, especially the first and last columns won't have three choices, but all the in between columns will have all the three choices. So that is what we need to remember. So what we are essentially saying is sum of ij will be the minimum of ij plus I minus 1 j. So we are saying, even though I am saying ij, I minus 1 j, right? So you need to think like the contents at that particular location, okay? So keep in mind, we are only using the indices here just to understand, but we are not exactly adding the indices here, but the contents of those indices or those cells, right? So once you have the sum, right, you will be able to generate the minimum thing, right? So at the last row, right, at the last row you will have all the sums calculated. So now what we what we need to do is, you need to find the minimum of the last row, right? So that is the final step. Finally we go through the last row of the sum 2D array and find the minimum from it, right? So we will be going to go and look at the code for this, right? So it's the same approach that we talked, right? So minimum falling path sum. So let's get the m and n. So although the m and n are same here, I purposefully got it differently, right? Even though it is given as a square, I purposely got it as different. You can just use a single variable, there is no harm in it, right? And once you declare this, what we said is initialize the sum array element to int max value. That is what is being done here. And the next thing is fill the first row with the first row in the input, right? So that is what we are doing in this for loop, right? And the next thing is, so this is where the actual logic, so the three conditions, right? So the three conditions will start right here. So since we already filled the first row, we can start from the second row. That is what we are doing here. So we are starting from the second row. So if j minus 1 is greater than 0 and j plus 1 is less than n, that means this is a middle column, right? This is a middle column, anywhere in the middle column. So in that case, you have three choices as we talked, right? So you have three choices: aij plus sum of I minus 1 j, aij and sum of I minus 1 j minus 1, aij sum of I minus 1 j plus 1, right? For the all middle columns. So this if is, it checks whether it is a middle column or not, right? And this one, so this one, it checks j minus 1 is less than 0 and j plus 1 is less than n. So this checks for first column. So for the first column, you have only two choices, right? So these two choices, that's it. And this is the last column. So j minus 1 is greater than 0, but j plus 1 is greater than or equal to n. In that case, this is the last column. So you have three scenarios. This is the middle column, this is the first column, and this is the last column. That's it. So we covered all the columns, right? So finally, we get the minimum sum in each row. But what we are interested is minimum falling sum across the board, right? So that will be at the last row. So what we are going to do is going through the last row and finding the minimum in the last row. So finally, we are going to return that minimum, right? So whatever the sum that we have obtained in the last row, you have to choose the minimum of the sum. That will be the answer for our question. So let's go ahead and look at the time and space complexity for this algorithm. So let's look at the time complexity first. Okay, so time complexity will be, for this for loop it will be order of m, this for loop it will be order of m and m into n, this for loop order of n, and for this order of m minus 1 into n. So even though I already said m and n are same, I purposefully took m and n as different, but you don't need to worry about them. So what we can say is the total complexity here will be order of m into n. So if you add up, everything will be order of m into n. In other words, you can just say order of n square as well, right? So in other words, you can say order of n square as well, since the problem given is a square matrix anyway, right? So you can say order of n square. That is also works. So similarly, if you look at the space complexity, right? So we are declaring a sum array which is equal to order of m into n again. So you can say it as order of n square, right? So the time complexity and space complexity, both of them are order of n square for this particular algorithm. So if you have any questions, please post them in the comment section. I will get back to you on this. Thank you for watching. If you haven't subscribed to my channel yet, please go ahead and subscribe, and don't forget to click the bell icon. You will get the notifications for all my future videos if you click the bell icon. Please share among your friends as well. Again, thanks for watching. I will be back with another video very soon. Till then, bye.